Welcome back to G Fun Facts Online. Today, we are diving into a subject that covers 71% of our planet, but often remains a mystery in the conversation about climate change. We are talking about the ocean, the silent engine of our planet's stability. For thousands of years, the ocean has been absorbing the heat of the sun and the carbon dioxide exhaled by the Earth. But recently, that engine has started to sputter. The ocean has absorbed roughly 30% of human-made carbon dioxide emissions and 90% of the excess heat generated by global warming. The result is a marine environment that is hotter, more acidic, and gasping for oxygen. But there is a solution growing in the cool, sun-dappled columns of the coastlines. It is slimy, it is often overlooked, and it might just save us. We are talking about seaweed and the blue carbon revolution. To understand why scientists and engineers are suddenly obsessed with seaweed, we have to look at the concept of blue carbon. For decades, we focused on green carbon, which is the carbon stored in forests and soils. We all know we need to protect the Amazon rainforest. But terrestrial forests are vulnerable to fire, drought, and logging. Blue carbon refers to the carbon captured by the ocean and coastal ecosystems. Historically, this meant mangroves and salt marshes. These are incredibly efficient, burying carbon 10 times faster than a tropical rainforest. But they don't cover much space. Seaweed, or macroalgae, was originally excluded from this math because it grows on rocks, not soil. Scientists assumed when it died, it just dissolved, but groundbreaking research published in 2025 has shattered that assumption. We now know seaweed farms act like a conveyor belt. As the algae grow, they slough off organic matter that drifts down to the seafloor, locking carbon away for centuries. This is the seaforestation of the ocean. Seaweed is biologically fascinating because it is not a plant. It is macroalgae. It doesn't waste energy building roots or trunks to fight gravity. The water supports it. Every square inch of it is photosynthetic. This allows species like giant kelp to grow up to 2 feet per day, making it one of the fastest growing organisms on Earth. In doing so, it sucks up carbon dioxide and nutrients with incredible efficiency. We generally categorize them into the browns, the massive kelps that act as heavy lifters for carbon, the reds, which are smaller and protein-rich, and the greens, like sea lettuce, which are amazing at cleaning water. The primary way these organisms cool the planet is through the biological pump. In the surface ocean, seaweed converts dissolved CO2 into biomass. This creates a deficit in the water, causing more atmospheric CO2 to diffuse into the ocean to restore balance. Essentially, the seaweed is scrubbing the sky. But the trick is keeping that carbon locked away. Current research identifies 3 pathways. First is deep sea sinking, where massive floating islands of kelp are intentionally sunk to the abyssal plain, trapping carbon under immense pressure. Second is refractory carbon export, where the seaweed releases complex molecules that bacteria cannot eat, so they drift in the ocean currents for years. And third is sediment burial. A major study by Oceans 2050 found that carbon from seaweed farms accumulates in the mud below, just like in a mangrove forest. But carbon dioxide isn't the only enemy. Methane is over 80 times more potent at trapping heat in the short term, and a huge chunk of it comes from cow burps. There are 1.5 billion cattle on Earth. This is where the red seaweed Asparagopsis taxiformis becomes a hero. Researchers in Australia found that adding just a tiny amount, less than 0.5%, of this seaweed to cattle feed practically eliminates methane production. It contains bromoform, a compound that stops the methane-producing enzymes in the cow's gut. Companies like CH4 Global and Symbrosia have refined this, finding that using the whole seaweed is stable and effective. If we scale this, we could cut a massive lever of global warming almost immediately. Then there is the vision of marine permaculture, championed by the Climate Foundation. Global warming has created a warm lid on the ocean surface, preventing nutrient-rich cold water from mixing up. This creates ocean deserts. Marine permaculture uses lightweight lattice structures submerged below the surface, equipped with wave-powered pumps. These pumps pull cold, nutrient-dense water from the deep to irrigate the kelp forests above. This grows biomass, restores fish habitats, and cools the surface water, potentially even preventing coral bleaching in nearby reefs. Beyond just carbon, seaweed offers critical ecosystem services. It fights ocean acidification. As the ocean absorbs CO2, its pH drops, dissolving the shells of oysters and corals. Seaweed strips that CO2 out so fast, it creates a localized halo of health, raising the pH and allowing shellfish to thrive. It also boosts biodiversity. A seaweed farm is a hanging garden, acting as a nursery for fish and a hunting ground for seals. It also cleans up coastal pollution by soaking up excess nitrogen from agricultural runoff. Economically, we are seeing a boom in seaweed applications. We are drowning in plastic, but companies like Nopla are making seaweed-based packaging that is fully edible and biodegradable. We are also looking at biostimulants, where seaweed extracts replace synthetic fertilizers, reducing nitrous oxide emissions. And the dream of seaweed biofuel is coming closer to reality, thanks to automation technologies reducing harvest costs. However, scaling is the industrial challenge. Most seaweed is currently farmed by hand in Asia. To impact the climate, we need to move to industrial farming in the rough waters of the North Atlantic and the Pacific. Companies like Ocean Rainforest in the Faroe Islands are deploying mechanized rigs that can survive massive waves. In Namibia, Kelp Blue is planting giant forests to capture millions of tons of carbon. But engineering for the open ocean is a nightmare, and we have to solve the logistics of transporting heavy, wet crops. There are also risks. We need to prove the permanence of the carbon storage to sell credits, and we must avoid monocultures that could damage wild ecosystems. We need a mosaic approach, using native species and careful monitoring. We are standing at the precipice of a new relationship with the ocean. Instead of just taking from it, seaweed farming allows us to work with the ocean's natural cycles to heal the atmosphere. It is a regenerative economy. From the deep-sea sinking projects of Running Tide to the methane-busting farms of Tasmania, the blue carbon revolution is underway. It is not a silver bullet. We still need to stop burning fossil fuels, but seaweed offers us a solution that heals as it works, buying us the most valuable resource of all: time. Thanks for listening to G Fun Facts Online.